Hi, this is the second video in a series of 3 videos that I've put together to show you how to use Docker Swarm to run a Windows and Linux mixed-OS containerized application. As a reminder, I put these videos together based around an example application that I created that has a Windows front end and a Linux back end. So the front end is just a basic web application, and then the back end is a simple Redis data store. Now, if you're coming in here and you haven't watched the first video, I highly recommend that you go back and at least watch the first parts of that video where I go over the application that I'm using in this demo. Okay, so to set the scene here, in part 1 of this series, we worked on initializing the Swarm cluster itself. We had 3 nodes, 2 Windows nodes and 1 Linux node, all running in Azure as VMs, and we initialized one of them as a manager node, then added the other 2 as worker nodes to the Swarm. In this video, we'll be setting up the application itself. So I'll go ahead and return to the diagram of the application and cover what we've already accomplished, and then we'll move on from there to setting up the application. So again, we have 3 hosts all running in Azure as VMs. 2 of them are Windows, 1 of them is Linux. They're all attached to the same network. In the last video, we went ahead and initialized these 3 hosts as a swarm by running this docker swarm init command from one of the hosts. That host became the swarm manager, and then we were able to use this docker swarm join command within a unique swarm token to join the Windows and Linux worker nodes. Also in the last video, we went ahead and added labels to each of our nodes, which, as you'll see, will help us in defining the application during this video. So the labels were very simple, just labels that give us a way using Docker to know which of our hosts are Windows and which of them are Linux. So 2 of them were labeled as Windows, and then our 3rd host is labeled as a Linux node. Okay, so as we go ahead and set up the app itself, we kind of have 2 tasks here. The first one is to create the application overlay network. This is the virtual network that will connect all of our endpoints for each of the services so that they're able to communicate across the cluster. After the overlay network's in place, we'll go ahead and create the database and web services attached to that network. Alright, so to create this overlay network, all we need is this very simple docker network create command. Alright, so from here, I'll head over to my Windows Manager node. I do believe, before I move on, that in the last video I forgot to explain the difference between manager nodes and worker nodes. So for those of you who don't know, basically the difference is that manager nodes have a concept of the swarm state. From a manager node, you have the power to do things like create overlay networks, create services, view the nodes that are currently a part of the swarm. But from worker nodes, you can't do things like that. So for example, if I wanted to simply view the nodes in my swarm, I can see that I have 3 nodes in my swarm from the manager node. I'm able to view that information. But if I try to do the same thing from my worker node, I get this error message that this node is not a swarm manager. Alright, now with that said, let's get back to creating the overlay network. And again, this is something that has to be done from a manager node. So I just use my docker network create command to do that. I need to give it the driver type, which in this case is overlay. And now for any situation on Windows where you're running an application across multiple hosts, you'll need to use the overlay network driver. It's the only Windows container network driver that allows cross-host communication between container endpoints. Okay, and then I'll name my network. So I'm going to name it HelloNet. Okay, so now it's created and I can view the network using Docker network list. And there we go, we can see it right here. Okay, so now that the overlay network for our application is created, we can go ahead and create the services themselves. So first I'll create the backend service, the database service. I have the command to do that here, so it's a simple docker service create command. In this case, I'm naming the service database, or DB. This name is the name by which the service will be available on the overlay network using service discovery. And then I have the endpoint mode DNSRR, so I'm setting the internal load balancing strategy for the service to be DNS round robin. I'm attaching the service to the HelloNet network that I just created. I'm also constraining the service to run only on Linux because it's a Linux-based service. Alright, so now I'll go ahead and copy this command from my notes here. And again, this is something that has to be done from my manager node. And that's done. And I can view that it's been created by doing docker service ls. And there we go, I can see that my database is there and it's running one container instance. Okay, so now we can move on and do the same thing with the front end part of the service. So the command is very similar to create the web service. It's docker service create. We give the name of the service, which in this case is web. Again, we're using DNS round robin as the internal load balancing strategy for the service. We're attaching the service to the Hello Net overlay network that we created before. In this case, we're constraining the service to run only on Windows host because it's a Windows-based service. And then we're providing the image for the service, which is called Hello Count Web Plus. Again, this is a Windows Server Core base container image that I took and installed IIS Web Server on, and then put my Python-based web application on. The only thing that's different here compared to the database docker service create command is this publish mode argument here. So what this is saying is that when this service is created, Docker should publish the service on container port 8000 and then some host port. So each of the web container instances will be available via their container port 8000 and then some port on whichever host they're running on. Alright, now let's go ahead and go to my notes and copy the command to create this service. Again, head to my manager node and paste that command. And then if I do docker service ls again, list my services, I can see my database service and my web service both are up and running with one container instance. Okay, so at this point the application is up and running with one container instance defining each of the services. So we can go ahead and actually view it. So because of that publish host argument that I gave the web service, the container instance for the web service is available via publish port on its host. So let's go and investigate that. So if I go docker service ps web, I can look at the processes specifically running for the web service. In this case, there's just one, this web.1 container. I can see that it's running on Kali 1, so it happens to be running on this node, my manager node. And then if we scroll over, we can see the port on which it's published. So it's published on this node and port 29175. So if I remember that port, I can go to one of my other hosts, because all of these hosts are routable to one another. And in the browser, I can put the address Kali1 where I know this container is running, and then the port. And there we go. So there's the application. And all this application does, it's a super simple Python-based web application that just counts how many times this web service has been accessed. And as you can see, although the count here is tracking as expected because this number is being stored in the Redis backend, the container ID and container IP here for the container that's handling this request isn't changing. And that's of course because we only have one container instance running for the web service, so it's handling all of these requests. Alright, so now that completes the first and second parts of this series, where I initialized the Swarm cluster and ran my mixed OS Windows and Linux application on my Swarm cluster. Now, in the third and final part of this series, I'll be showing how to scale the web service and the web service portion of this application, and then load balance across the container instances for that web service using an external load balancer. In this case, that happens to be an Nginx load balancer that's running in a container on another host.